Thank you, everyone, for having us today. My name is Amy Labar. I am a member of the Plug and Process Load Technology Research Team as part of the Better Buildings Alliance, and then I work with the K through 12 partners for the low carbon pilot. And I'm joined by my colleague, Dr. Kim Trenbath, who is also on the Plug and Process Load Technology Research Team, and she'll be joining us during the Q&A portion and sharing some of her expertise there. So it seems like we have, as Hannah said, an interested group in learning about plug and process load control strategies, and looks like there is room for growth. So I think you will hopefully get quite a bit out of this talk today. So next slide, please, Derek. So plug and process loads, or PPLs, are all plug-in and hardwired loads not associated with other major end uses. It includes things such as coffee makers, laptops, vending machines, laundry equipment, and escalators and elevators. So there's a very wide range of the types of devices that are included in PPLs, and they have varying levels of energy consumption. You may be wondering, why would I care about the energy consumption of a single device like a coffee maker? And the answer is that all of this energy consumption from PPLs really adds up. There can be thousands of individual PPLs in a single commercial building, and their aggregated energy consumption has a huge impact. Next slide, please. So currently, plug and process loads account for 47% of US commercial building energy consumption, and that figure is expected to increase as other building end uses continue to become more efficient and more electronic devices come online. Most building owners have put off addressing plug and process loads while they tackled other end uses such as lighting or HVAC, but plug and process loads are becoming a growing piece of building energy consumption, and it's time to start addressing them. So hopefully this presentation gives you somewhere to start if you have not begun your plug load journey, and if you have already started, I'm sure there will be some new information in here for you as well. Next slide. So we're going to talk about how plug and process loads can contribute to your low carbon strategy. The first way that we can address get to low carbon is by addressing your building's base load. So the first step in the decarbonization priority waterfall is energy efficiency. Before you tackle on and off-site renewables, grid interactivity, and carbon offsets, it's important to make sure your building is as efficient as possible. You want to minimize that wasted energy consumed by plug loads or other end uses. So reducing PPLs can have a huge impact on your building's base load. Consolidating plug and process load devices can reduce PPL energy consumption by up to 50%, and current control technologies can cut PPL consumption by up to 30%. Next. Grid interactive efficient buildings are another way to lower your building's carbon footprint. Integrating PPL control systems with the building automation system can enable these grid interactive efficient buildings. This will allow for whole building response to grid signals and allow the building to shift, shed, and modulate all of its loads, which will become increasingly important as more renewables come on the grid and the energy sources are more volatile. Next slide. And then finally, electrification can also contribute to lowering your building's carbon emissions. So within PPLs, we're talking about replacing gas-powered equipment with electric. Most common gas-powered equipment is in kitchens and laundry rooms. So these would be the types of devices that you would target with electrification. A key thing to note with this strategy is that you want to make sure that your building's electrical system is robust enough to allow high power and high voltage electric equipment to come online. So it's something to check before you decide to make this electrification switch. Next slide. So we're going to focus primarily on Ppl reduction strategies today, which is targeting that first method that I mentioned, which is reducing your building's base load. So there are two primary ways to reduce the base load. One is through control technologies. So these are devices and systems that turn off PPLs based on a schedule, occupancy sensor, or activity sensor. And then there's also management strategies. These are things like occupant engagement, encouraging them, your occupants to have energy saving behaviors, and building policies like consolidating equipment and procurement specifications for the equipment that you put into your building. Next. We'll start talking about the control technologies first. I'm going to touch on 4 of them. The first is low power and sleep settings. So these are available on many devices. Some are enabled out of the box, and others are not and require the user to enable these settings. So this is something to keep in mind and check on your existing devices in your building. The Community College of Allegheny County presented on a recent plug and process load technology research team webinar, and they were able to save 74% on their campus computer energy by enabling sleep settings that had been previously disabled. This did not require any capital cost, just creative thinking and some help from their IT department. So there's a link to the webinar here if you want to learn more about that energy saving strategy. Another control technology are advanced power strips. So these look like regular power strips, but some other outlets are controlled based on timers, activity sensors, or other outlets on the power strip. The timer capability will power devices off at certain times of the day. This is especially useful for controlling devices that don't need to be on during unoccupied hours. Some APSs have one outlet dedicated for a controlling device, and that device's activity controls other outlets on the power strip. So this is useful for workstations where a computer would be plugged into the controlling device outlet, and when the power strip senses inactivity, it powers down the other outlets that could have auxiliary devices such as monitors, speakers, and printers plugged in. We have a fact sheet linked at the bottom if you want to learn more about advanced power strips. Next slide. So smart outlets are another great control technology that has been gaining traction in buildings. Smart outlets are wireless meter and control devices that sit between the wall outlet and the Ppl device plug. And they are able to operate as a system, which is different from the advanced power strips, which are just standalone devices. So the smart outlets are able to communicate with a central system for someone like a facility manager to access energy metering data and controls from a dashboard. When the system is installed, devices are, where devices are plugged in are logged in the system, so the user could apply specific controls to a certain device type or to a specific location in the building. And then the final control technology I'll touch on here is automatic receptacle controls. These are similar to smart outlets in that they operate as a system, but they actually replace the receptacle in the wall. And the controls are commonly sent via hardwired communication pathways rather than wirelessly. Some ARCs have one controlled outlet and one regular, and others have both outlets being controlled. Most have an override button on them so that if the outlet is shut off, but an occupant wants to use it, they can press the button and override the control so that they can still use the electricity. These automatic receptacle controls are typically controlled via schedules or occupancy sensors. They can actually be tied in with most lighting control systems as well and use those same occupancy sensors that the lighting system is using. ARCs are the only technology currently on the market that meet building energy standards such as ASHRAE 90.1, Title 24, WSEC, and IECC. Next slide, please. All right, so we'll touch a bit on the management strategies here that you can also implement in your buildings. These management strategies could be used on their own, or they could be used in tandem with the control strategies that we just talked about. There are 2 categories, building policies and occupant engagement, excuse me. So building policies include actions such as timing software updates, scheduling the updates at times closer to business hours, which allows the equipment to be shut off during non-business hours and saves energy that way. Another policy is consolidating loads. This entails replacing redundant loads with one larger load of the same type. So for example, there could be 5 small printers spread throughout an office space, but this could be replaced with one larger printer that serves the whole office and reduces the plug load that way. Replacing inefficient equipment with energy efficient models is another great way to reduce energy use. But of course, it is not always cost effective or sustainable to replace equipment before it's reached its end of life. So you could also incorporate energy efficient specifications in your procurement process or in your low carbon pilot action plan. That way you're planning for future energy savings and you have that plan in place to purchase the more energy efficient equipment. Occupant engagement is a very important part of addressing plug and process loads. The occupants are the ones who will be interacting with the devices and equipment, and they can have a huge impact on how much energy the plug and process loads consume and how successful your energy saving strategies are. So some examples of occupant engagement are trainings for both new and existing occupants, educating them on the Ppl reduction strategies used in the building, sending regular emails or using pre-existing communication channels such as Slack to keep occupants informed and engaged with the Ppl reduction strategies is very important. And some other examples are conducting turn it off campaigns and posting signage to really engage your occupants. The plug and process load technology research team hosted a webinar recently highlighting some of these management strategies. Our very own Paul Torsellini was one of those great presenters. So there's a link at the bottom of the slide if you want to learn more about that. Next slide, please. So no matter if you're using a control strategy, a management strategy, or some combination of the two, there are some best practices that you should always follow when implementing a plug and process load reduction strategy. The first of which is designating a Ppl champion. So this is an individual or a team of people whose goal is to initiate and help with developing a Ppl control strategy and make sure that the strategy continues. Plug and process loads are often specified by multiple parties, and strategies are rarely developed just by one decision maker. So the Ppl champion ensures that all of those decision makers are there and on the same page, and that their decisions will save energy and integrate well with other building systems. Another best practice is institutionalizing Ppl reduction practices. So again, the champion should work with decision makers to incorporate the Ppl energy saving tactics into the building policy, such as purchasing only energy efficient equipment or requiring the use of low energy states wherever possible. You also, it's really important to develop a business case for the Ppl reduction. This is critical for getting buy-in from all parties involved. You will want to identify which reduction strategy you would like to target, whether you want to control all devices in your building or if there are a few specific devices that seem to be consuming the most energy and you want to target those for controls. It's important to identify which strategy you want to go after. And you also want to consider non-energy benefits of plug and process load management. These are things like improved indoor air quality from maybe consolidating your printers or copiers in your building, and then also asset management. So these plug and process load control systems are able to track the energy consumption of the devices in your building, and they might indicate when a device is nearing its end of life, or if it's just consuming way more energy than you thought it would be, and it's time to be replaced. The systems will also allow you to track device utilization. Maybe you have 2 of the same device type within the building, but only one of them is really being used. You can identify good opportunities for consolidation and energy savings that way. And then finally, another best practice is educating employees and occupants on the benefits. So I touched on this with the management strategies a bit, but occupant engagement is so important, critical even to the success of your plug and process loads. So you really want to make sure that your occupants and employees know how the system works and how it will save energy in the building, what actions need to be taken to save the energy. Do they need to put the appliances in low power mode? Do they need to monitor a dashboard? Do they need to adhere to a certain schedule, etc.? And then how to reset or adjust the controls in the event of a malfunction or schedule change. We've seen a couple instances of these plug load systems being deployed in buildings, and they do not educate their occupants appropriately. And the system shuts off an occupant's device when they're not expecting it to because they didn't know what the schedule was. It just creates occupant frustration and ultimately prevents the building from wanting to have these types of systems in their buildings moving forward. So occupant engagement is very important. Next slide. So I wanted to provide some other considerations here for those of you who have tenants and are leasing your building space. One way to encourage your tenants to adopt PPL control and management strategies is to establish corporate guidelines requiring PPL management. You could provide trainings for occupants to turn off or unplug their electronics and appliances when they're not using them. And you could also provide control technologies for the tenants. Advanced power strips are a great option for this. They're relatively inexpensive and very easy to install. Should also consider implementing a green lease or performance-based lease. This would allow you to set PPL performance goals and keep track of their progress using submeters. And you could also include PPLs in the tenant's energy consumption limit. If you're interested in learning more about these leases, reach out to Hannah Debelius. She has lots of great information about those. Next slide. All right, so I wanted to hit a few of the emerging technologies that are coming out that you should keep your eye out for. First is automatic and dynamic load detection. There's learning behavior algorithms which use artificial intelligence, and then integration, which we've touched on a little bit, but I want to go into a bit more detail on that. Next slide. So automatic and dynamic load detection, or ADLD, identifies devices as they are plugged in and keeps the plug load management system up to date. So we see this primarily being used in a smart outlet-based system. It would allow the system to be plug and play by reducing installation time and reducing issues arising from devices moving around. So this technology would be most applicable in buildings where we see the plug load devices being moved around from outlet to outlet in daily use. This would ensure that the correct control schedules were being applied to those devices. This is still a relatively new technology. It's expected to become available to the market within 3 to 5 years. Next slide. And then learning behavior algorithms, or LBAs, use artificial intelligence to optimize the plug and process load control schedules. They spend time learning occupant behavior through their energy consumption to really maximize the amount of time that they can power these devices off and save energy. And there are at least 5 companies developing or already offering products with this technology. So if you're looking at smart outlets or automatic receptacle controls, keep an eye out for this capability for them. Next slide. And the last emerging technology I wanted to talk about was integration. So a number of buildings and campuses around the US are starting to integrate plug and process load controls, both with their lighting control systems and their building automation system. So the lighting control systems integrate really well with automatic receptacle controls. I think I mentioned this earlier. You can use either the same control schedule or the same occupancy sensor for a space to control both your plug loads and your lighting loads. And then some smart outlet companies and automatic receptacle controls are able to integrate with the building automation system. And this is really where you can gain whole building control and start to get into that grid integration piece, respond to grid signals. So we have a webinar coming up, the Ppl Technology Research Team on March 22nd. We're going to have the Minnesota Department of Transportation and University of California, San Diego presenting on some of their integration experiences. So we have the registration link here that you can access from the slides.